Welcome to EIG's 36th webinar, Visual Insight for Safety, Practical AI Solutions for Your Business. We appreciate that you're taking the time to attend EIG's webinar series on building an evolving, resilient enterprise, especially in light of the continued coronavirus pandemic. I'll be happy when I don't have to say that any longer. Hopefully we'll be out of this soon. But most importantly, we hope that your family are healthy and safe. This is the fourth webinar in the series. Our first webinar was on OCR. Our second webinar was on image to insight. And our third webinar was on video on April 27th. Today, we will focus again on video, but from a safety perspective. And then our next webinar, we thought we'd mix it up and have a fireside chat on what problems can be realistically managed and solved with artificial intelligence for visual and audio worlds. We look forward to an interactive webinar, and we have polling questions throughout, like our opening polling question. And so please do have your cell phone handy or have another window open and look into the chat to pull up the poll EV. My name is Jim Vries, founder and president of Enhanced International Group. EIG is a platform of 40 plus consultants, consulting companies, and SaaS solution providers. And we're dedicated to empowering your organization's workforce to expand and sustain your organization. Our goal is to provide collective, collaborative, experienced thought leadership to enable your organization to deliver self-sustaining, positive margin growth. We focus on 90-day action plans, and we thrive at combining our talents in our group to provide that 1 + 1 = infinity for you. We do focus on people, process, data, and technology. We believe that we need people and process first before we get into data and technology. So we don't espouse putting in a technology solution without the people and the process and the data to support it. And we'll talk more about that at the next webinar. Our upcoming webinars are on July 15th. Of course, next week is a holiday in the US. So we'll have a fireside chat on new product introduction and digitization. Then we'll have, the following week, we'll have digital transformation and for digital twins, a demo with interactive Q&A, and then we'll move to another interactive fireside chat on the trade-offs between lean and supply chain risk management. It should be an interesting discussion. And then on our fourth webinar is on de-risking large-scale projects with the AIM Institute. And then wrapping up the month, we're back at supply chain risk and resiliency. In the beginning of next month, we're back here with this team on the fireside chat discussion as we discussed before. Today, we're fortunate to have with us very highly respected leaders in the field of artificial intelligence, Dr. Bulent Uyaniker and C. Bunevich. Dr. Uyaniker, a few words of introduction.
Thank you very much, Jim. Thank you, first of all, for you, EIG, and Fusemachines, and Carol especially, for organizing all this. It's been a fantastic journey just trying to explain all these projects, the bottlenecks in the AI throughout these seminars. And thank you, everyone, spending time and joining these webinars. Thank you very much. I'm a physicist, and I have worked on imaging all my life. That includes satellite imaging, radio antennas, interferometers in several countries, and including medical imaging, breast cancer research. And with DataSpeckle, we are providing on-demand teams for businesses in North American and European markets in computer vision, machine learning, natural language processing, and deep learning. We would be happy to know about your problems, and we would be very happy to be part of the solution of your problems And please reach out anytime on anything, and we'll be more than happy to chat with you. Thank you very much.
Thank you, Bulent. C?
Sure. I'm C. Bunevich. I also go by Carol. I tell people I was Carol in the last century, but I thought in the new century, it's good to mix it up. I'm VP of Partnerships at Fusemachines. Fusemachines is an AI talent consulting and education company with a social mission to democratize AI. What we do through our social mission is we teach young engineers in developing countries and in the US all about AI through a number of different programs from middle school through college. And we're always looking for folks who want to be part of our team, whether through teaching or mentoring, or just want to learn more about our social mission. So I encourage anybody who has any interest in helping young people understand AI and understand what a career in AI could be to reach out to me. And I'll be happy to get you involved. Thanks.
Thanks, C. With that, I think, C, maybe you'll kick us off with...
Sure. Just to review, I mean, Jim did this a little before, but this is a series on practical AI. We started off on educating people about OCR, and OCR is like a first tool to help people move into digital transformation. And then our second in the series, and as I mentioned, all of this is available on the website, and I have the website in the chat. Second webinar, we worked on image to insight and talked about the Altman Z-score. And in the third webinar, which was video to insight, we talked about merging the video or visual and audio worlds. We did a second part to the video insight. Well, actually, we're doing today, the second part of the video insight. And today we're going to focus on safety in the workplace. And our next in the series will be on August 3rd. And we are going to talk about the problems that can be solved with AI. And we want people to come with problems, and we can, discuss, are these appropriate AI problems? Thank you. Today, we'll just review initially what we've gone over in the past very quickly. And then we will move into talking about a new algorithm, or I should say a customized algorithm that Bulent has developed, focused on human pose. So that should be very exciting. And then we're going to talk about object classification, both in localization and tracking. And then about extracting information within a video. And we'll then talk about the AIDER framework, which is how you figure out if you have a good problem to solve through AI. And then we will do a safety case study. And finally, we'll do Q&A. But I would love people to just put your questions in the chat, and then we will answer them throughout. So I'll be looking in the chat for questions. So just chat away. Thank you, Jim.
Thanks, C. Yeah, please chat away, as C said. I love it. So this is a study that was performed on the 2021 computer vision application trends. And there's quite a number of trends that we're looking at. And from this study, it showed that ensuring people are safe in the workplace is clearly a #1 application trend. So we thought we would focus on that. But also the #3 area is thermal imaging analysis, which is also part of this webinar that Bulent will cover in a few minutes. There's many applications in AI, real-time application of edge computing, and hands-on through sensor data and averaging, looking at closed loop systems, solutions, and of course the video analytics. So there's quite a number of AI applications that are coming up in this world, and more are to follow. From a safety perspective, we found this from the National Safety Council in the US. The amount it's costing us, these numbers are a little bit dated from 2019, but I think still apply. They're only going to be higher now. But this is a US-based council, independent council funded by the US government or supported by the US government. But it shows in 2019, the cost of safety cost $171 billion. And per worker, it's about $1,100, and per death is 1.2 million. And per medical consultant injury, about $42,000. So it's quite a large impact, especially those folks in the construction industry and in the manufacturing where there's large equipment and machinery, but it can happen anywhere in the workplace. The amount of days lost, which goes direct to your bottom line, that's really unrecoverable, is at 105 million days lost in 2019, due to injuries, 70 million days, and then due to injuries in prior years, 35 million. And in future years of 2019, 55 million days. So, you know, the days lost, as it shows there, do not include the loss by people with non-disabling injuries or other people directly or indirectly involved in these incidents. So some pretty significant numbers nonetheless, and it's at the foremost thought of all the executive leaders is how do we make our environment a safer place? So that's the reason for this webinar and the reason we wanted to focus on this today. Just going back to our previous webinars on image to insight, we have the document image or it could be a video image. And the overall goal is for us to be able to turn these images, photos, videos into ones and zeros. And by turning them into ones and zeros, we're able to perform deep analytics on them, deep learning. But the question is there a sufficient data in our ERPs today? And generally, the data sources that we have today aren't very rich in information that we can make better decisions in. So the question is, where does this data exist? Well, it can exist in documents and optical character recognition, intelligent character recognition are certainly areas where we can get better at. And we have, in the last 20 to 50 years, a tremendous amount of focus in this area of being able to read image text and tables. But when you have 1,000 pages or a book, it becomes more difficult. Or if the pages of the books are degraded, or if your images are degraded, whether they're pictures or even videos, if they're degraded. So degraded images or pages, you're going to need some additional AI types of technology and computer vision, pattern recognition, probabilistic approach. So there's many new developments and bigger and stronger computers to be able to analyze these types of environments. And then our fourth area is where there's no digital data exist. There's just too many pages of documents or, reels and reels of video. How do we get in there to find out and target an area within a document or a video on where the focus is? And then as we learn more and more about the process, we're able to then leverage the processes in 2 and 3 that we just discussed. So we want to do this in the most efficient and effective manner as possible so that we can get it to a stage where we can use a lot of the technology that we hear a lot about today, which is process mining, machine learning, intelligent process automation. We need to be able to get the data into a clean environment so we can make those good, valuable decisions to help our workflow in our environments. So that's a bit of an overview, and then I'll turn it over to Bulent.
All right, thank you very much, Jim. That was a wonderful summary. So I'm not going to spend much time on these things. Many of those we have already discussed because I would like to make time brainstorming and discussion, and we would like to have this as interactive as possible. So basically, information is coming from many different channels. It is coming from text, it's coming from speech, voice, it's coming from images, and obviously it is coming from video. In all of them, there are several different ways that we approach the problem. We need to just change the strategy, the tools sometimes, but end goal is we would like to extract information from whatever the channel is. If it is text, we would like to convert those text into meaningful, semantically understandable parts of speech. If it is speech, obviously we would like to convert that into text and understand the language and pass that information and use that information somewhere. The same thing is valid for the image and videos. We use mostly machine learning algorithms to do that, and there's several techniques we use in machine learning. Obviously, machine learning, robotics, and natural language processing, they all just parts of the big umbrella that we call AI. For natural language processing, obviously, we go for translation, OCRs, text clustering, and text mining, extracting information from any source. It could be financial documents, web, or anything written. It could be even the traffic signs that we can extract information and even translate them. Speech is very important, and we probably have to tackle with that one separately. We did webinars on OCR and clustering and information extraction, mostly NLP related things. Maybe we can go a little bit deeper. We have done mostly on the images. Today, we are going to be concentrating more on extracting information from images and videos for safety purposes, and we will just continue with vision. Moving on, actually, we would like to really talk more about images and what kind of algorithms and approaches we usually use for images. The first thing is obviously the understanding the scenery, figuring out what is an object, what is the topic of that still image, or what kind of object we are seeing in an image. So that is basically the classification. So we have several objects, and we would like to figure out whether there's a cat or a dog in a given picture. So pictures are not really different than video, obviously. The whole starting point is trying to understand the object and trying to figure out what kind of object we're tackling with. That we call as object classification. Obviously, object classification is a good thing. We can understand whether there's a cat or a dog in a given picture. However, there is more to that, because we would like to know where that cat is, or if there are more than one animal, where are they? And that's actually the location, and that requires a lot of texture and image quality, image depth information that we gather from the given picture. So that second thing is actually the one that is depicted here on the left with that green box, which simply does not only figures out that there's a cat in that image, it also locates the cat and says, here is the cat. Obviously, this is one thing, and we can go for the changes in the textures of the images, basically background subtraction idea, or image segmentation. So image segmentation, background subtraction is actually the basis of all the medical imaging that we see all around. And that also borrows a lot of ideas from space imaging. So basically, you try to look at an object and you try to classify it, localize it, and find its texture or just image quality differences with the background. In this middle panel, actually, we do see an example that's in a different wavelength, but for us, Any wavelength is nothing but just a signal. It's just a different wavelength. It just puts its signature on a different wavelength. It's a different physical phenomenon, basically, but in the end, it's an image. In the middle panel, we see an infrared image, and we see the same ideas of classification. So we do see people, and localization. We do see all these boxes and circles. We simply locate them. And background subtraction, and obviously infrared, is one of the very interesting wavelengths or windows to our universe, because it is sensitive to heat. And we can measure actual temperatures. We're not talking about night vision here. We're talking about actual temperature measurements, vibration of atoms. And the other part of that is actually going for, it doesn't matter which wavelength, continuous tracking of the movement, and obviously figuring out the joint skeleton, the limbs and the position, the peripheral information, the 3D information about the movement of the objects and tracking them. So that is going to be the human pose that we are going to be also talking today. It's in the third panel. Okay, before going into these, let's just try to refresh our minds a little bit about computer vision and deep learning, and what do we get, and what kind of algorithms we use for this. Different than machine learning ideas, in deep learning, if you ask me, one of the fundamental difference is we do feature extraction using the algorithm. We do not simply specify the curvature of the head and point the eyes, or just figure out where the ear is and so on. Instead, we try to extract all these features and many more of them using automated systems. That is actually the first part of any deep learning algorithm, which is basically a convolutional neural network algorithm as basis. Here in this slide, what we see here is, on the left-hand side, we have an image, and we would like to figure out, in this particular example, whether that person wears a mask or not. So what we do is, we simply employ this first part, that feature extraction part, using a technique which is simply a masking, a filtering technique that uses the mathematical operation of convolution. Basically, we have a little square, what we see here on that image overlaid, and we do a mathematical operation between the mask that we provide here in that little square of box and the image. And we take the result of that mathematical operation and move on to a different scale. Basically, from that one single box, we produce one single value, which is the most prominent value that we are looking for in that image. Depending on the mask, it could be a mask that is looking for the vertical lines. It could be a mask that is looking for some certain different parts of information. It could be looking for the average value. It could be looking for the median value. There's so many different filters, those masks actually called in computer vision, in traditional computer vision, as filters. So depending on that filter, as we see, since we are getting one value from that box, the next image that we construct from this original image will be an image smaller in size than the original. And if we keep doing this, we will see that we are going to be having different layers of information stacked on top of each other. So at every level, we call them layers. We actually probe into a different scale of information. And that is a fundamental difference between traditional machine learning algorithms and a deep learning algorithm. And at the end, where we have on the right-hand side, we have a flat layer, which simply means that we are simply putting all these tensor information 2D for each image. Obviously, if we have more than one image, it is going to be a 3D tensors. We need to flatten them and provide them into a classification algorithm. So every deep learning algorithm in this sort ends up with a classification algorithm at the top layer. And in the top layer, we simply create a multinomial result based on that sigmoid function that we usually use, the probabilistic values of the classification. So in this particular example, whether a person is wearing a mask or not, and the results are on the right-hand side, and based on that probabilistic values, we decide whether that input image belongs to a person who is wearing a mask or not. So a little refresher here, these are usually most asked questions. That's why we go over that. If we go one more step, then it will become more clear what do we mean by convolution algorithms, convolution step, and what do we mean by different scales and different layers of information extracted at every step. If we look at this one, so I don't want to be very mathematical over here. If we look at here, we see that big square with ones and zeros is our original image where the person is wearing mask or not. And that little yellow square is a sliding window that is just traversing through the whole image with certain steps. Those steps can be adjusted again. And every time it just passes over some certain area, it basically makes a multiplication of each corresponding square and adding them. So basically in the top big square, 3 by 3 square, where the mask lands on at first step, it simply multiplies ones and zeros. Every pixel of that mask is multiplied with every corresponding pixel of that image, and the result is written on the right-hand side. So the right-hand side, the convolved image, what we get is, as you see, a smaller image than the original, which is picking up all the prominent features from the original image. Moving on, we can actually see what kind of structures we are extracting from these images. At first level, we have the boxes or just the filter moving around. We see that we have low-level features. By looking at these low-level features, we are not going to be able to get any sense of that belongs to a person or a mask or anything, because these are very, very small features, because the mask is very small in comparison to the large image. And this could be just a little curvature in the image. It could be very tiny detail in the image, but by looking at them, we can't gather that information. We can't simply go back by simply looking at this feature and say that, oh, this is a part of the ear, or just a part of a nose or eye. But it will simply collect all that information. We could manually not possibly gather all that information one by one, or it's too tedious to get them. When we just move into layers further and further, we will start seeing different structures. Mid-level features, we will start seeing larger and larger objects. Obviously, they are going to be all smoothed versions of these images. And imagine now we have thousands of images as input. Then we will have a representation of a nose or an idealized version of an eye or an eyebrow, and we will have thousands of them. So in a way, we are teaching at every level, at every layer, we are teaching an algorithm what an eye should look like, what is the difference between a blank space and a nose, and so on. So, but these are all idealized ones because we have thousands of these smoothed versions of noses and eyes and eyebrows and so on. And for the high level features, we are simply going deeper and deeper into the layers, hence the deep learning name comes. We start seeing all these high level features on the right hand side. High level here means we do start seeing faces and so on, but because they are so much smoothed, convolved with this operation. We are not going to be able to recognize these people anymore. Here is just a representation, obviously, but we will have the idea, the algorithm will have the notion of the curvature of different faces and the arrangement of these other objects on a face and all this information. So these are just 3 different layers that we chose. Obviously, there are intermediate levels and so on. And we have currently deep learning algorithms that are starting from one couple of layers to hundreds of different layers, so that this will show us what kind of information we are extracting. Okay, now let's just move on and just come to more interesting part of what we can do with these things. Here are some examples, and Jim will lead us into those business cases and safety cases.
So the first case in the upper left-hand corner, of course, is what we all fear of being at home and all of a sudden having problems. So we were standing erect and now we are laying down. That's a case of that we need help. The one on the right side, upper right, is a common area in a power plant or a large factory where you have a switchgear. And this is a very dangerous place. One of the most dangerous places. It's off limits to anybody who doesn't know what they're doing in that area. So in the switchgear area, you have to have somebody being watched, and having something that watches people would be very helpful because due to lack of personnel, you might be there by yourself. If something were to happen, that is certainly a precarious situation. Of course, in the bottom left-hand corner, a gentleman already had a precarious situation of getting his foot stuck in there. Not sure exactly how they managed to do that, but forklifts running around. He might have been loading it or trying to unjar something on the forklift, and then all of a sudden his leg is stuck. So that's another situation. Of course, on a construction site on the right-hand side, you're building a large structure, and you have lots of crews there, and there's this boom crane that looks pretty precarious, swinging around. Everybody needs to be accounted for, where they're at, and the person operating the crane. Any additional information that could be provided using AI would be very, very helpful. So Bulent will take us through MMPros and other types of technology that can help us in these situations.
All right. So there are several ways to approach this, and obviously the idea here in this work site safety issue is to detect people. So we would like to figure out whether there is a person there in that particular image. So there are several ways of approaching this. As we said, one way is just trying to look for the textures and background subtraction and trying to figure out whether that person is there or not. So this is a good information. We can get all that, but in presence of multiple people in the image, this could be tedious. And at the same time, it is just producing very little information, because we would like to know whether the person is lying on the ground, or the position of the neck, the arms, and the legs, and such. So in that, actually, we have customized several algorithms together, and just we have produced all this. The algorithm that we are running, just the inferences, is actually extracting the limbs and some certain points on the body. Basically, the neck and the head and eye portion is represented here in green, and the torso is purplish, and I believe the legs were in blue. And here the approach is a top to bottom approach, if you are interested or have heard the name. So there are 2 approaches in human pose estimation: bottom to top and top to bottom. Top to bottom just tries to figure out the person, and then afterwards tries to find all these nodes. And the bottom-up approach is actually trying to find that nodes first, and then finding that bounding box that is representing or just figuring out where the location of the person. So moving on, there are just a couple of examples. These are basically the examples that Jim has showed us. So basically, we can run these algorithms, and we can not only figure out where the person is, but we can simply figure out the orientation of their legs. Obviously, blue lines here representing legs parallel to the floor is just telling us that someone is on the floor, or just lying, or just standing, or just kneeling down. All that information can be extracted, as well as the position of the head and neck and arms, as well as how many people in that image. So moving forward, we will see more and more complicated images. Obviously, the background here is a little bit difficult to extract, but still the algorithm is able to extract that information. The next one is going to be a little bit more crowded because there will be so many people. But again, you see that the algorithm is successfully locating these people all around, and their location at the same time, the limbs and the torso and their head positions. This is very important information, because if something happens in a work site, we can always be aware of what's happening and what the person is doing and what kind of problems they are facing with. The next one is going to be a video that is from a workplace. A person is working. Okay, so this one is a construction site again, just showing so many people. As we can see, the algorithm is able to detect all these people. These are very small excerpts, obviously, but the algorithm is able to detect all these people, locate them, and their body parts. This one was for, again, a manufacturing site, I believe. We have run the algorithm on that, and it is just showing us the arms, the vision of the arms, and what the person is doing. Obviously, we can figure out if the person is lying on the ground, something happens, the person is not working, or just approaching too close to some certain machinery. All these things can be monitored. And again, these just limbs are going to help us a lot. So there is a trade-off, obviously, when we talk about all these things. One question is, what is going to happen with the privacy? So we will try to address that question as well. So moving on, we will show you a couple of other use cases for the application of this technology, the AI technology, and we will have some discussion about the business cases, and further we will address the privacy case as well.
So where we're discussing that, we're asked for, what are some unsafe working areas in your company that you would want extra monitoring? So if you could type in at polev.com/Jim DeVries 073, or click the link that's in the chat box, and you can enter that in your cell phone by texting 2233 and then entering in that phone number 22333. You can enter in Jim DeVries 073, and then you can respond to the polling that way. So we have a few responses here. Emergency room, bathroom, that's a good one. Slipping in the bathroom is an area that is very dangerous. Bedroom, there we go. High stacks. Warehouse, subway. Yeah, subways are very precarious places. Sounds like some people have had some tough times in the bathroom. I can attest to that for sure, especially in the shower. The nice thing about the Pose type of software is that it protects your identity, but gives you that opportunity to find out if you have fallen, and every second counts, as we know. From the time something happens, seconds do matter. See, Bulent, any other comments on this?
Well, I'm
Great
just trying to
feedback.
follow. There are so many interesting responses here. Rooms and bathrooms. So basically, the houses seems like an interesting choice in this selection, in this polling. Hospitals are definitely one of the places. Residential houses could be, schools, public transport. I think these are very good responses. Garages are really good points. And maybe streets, dark alleys could be some places as well.
Yeah.
Or
Stairways.
yeah.
Yeah. Oh, good. Thank you for your participation there.
The question that we're going to deal with shortly is the trade-offs. And that's always a harder thing to answer, you know, and we'll have a polling question on that. But we all want safety, and most of us also want privacy. So that will be one of our future polling questions. Be thinking about that.
Okay. Great responses. Thank you so much. See?
Yes. So one of the things I hope you're thinking about today is what situations are you dealing with in your own work environment that might lead to a good AI project? And we just had a whole list, right, of streets, manufacturing, warehouses, hospitals, right? But figuring out what's a good AI project, understanding that AI projects, you don't snap your fingers and they get done in, 2 weeks. So these are the things that we'll talk about now and quite a lot in our next fireside chat. Number one, are there algorithms that you can work with and customize? Because typically what you're doing in your own AI project is working with, well, typically what we're doing when we're helping clients is we work with a lot of open source tools and a lot of open source algorithms, but then we customize them obviously to the specific needs. So that's one thing to think about. Probably the most important issue in any AI project is the data. What data do we have? What data can we acquire? So figuring out what the data challenges are upfront, totally the most important thing in figuring out your success. And as I like to say to people, data is 80% of the success of any AI project. So, I mean, the algorithms are important, but the data is far and away more important than anything else. In thinking about your possible project, you want to pick something that's going to have huge impact and is going to solve important business issues and help you with your ROI. And another thing to think about, and this is something that you would like to know in figuring out an AI project, is it's a recurring problem, because recurring problems will continue to feed more data. And the way you're going to have the most successful AI project is where you're constantly feeding more data into the system, because that makes your system much more accurate. Bulent, you want to comment on any of this? Maybe not.
I'm on mute. Sorry.
Oh, okay.
Data. I think you have highlighted that quite nicely. Data is the king all the time. Without data, none of them is possible. There's so many technologies, and we need to be a little bit flexible in applying the technologies at the same time. So first, we need to have data, and we need to have an appropriate problem that is recurrent, that needs the help of machine learning or deep learning algorithms. Then it is a lot easier to approach those isolated problems easier and find solutions.
We have an excellent question from Mark. Have companies applied this technology to reduce the need for, quote, a buddy in a remote or dangerous environment? Jim, do you want to answer that?
I think they're, with the GoPro cameras, you're seeing a lot of folks now being monitored. So I'd say we're moving in that direction. I think there's still a lot of opportunity yet to come. But actually using AI, I think that it's still a rich environment. So I think that there are some folks doing it, but most of the folks are not doing it today.
But it is, I think it's a goal of people. I mean, they
It's a goal. It's always discussed.
Yeah.
It's always discussed. It's a great point, Mark. But reality, I think we're still at the early stages here. So quite a bit of opportunity in the in those environments. Great question. Thank you, Mark. Any other questions? Should we go to the next slide?
Yeah, I think we should go to the next slide.
Bulent?
Well, there are so many applications, and most of the time, obviously, we try to address them in a different way. Most of the time, we do go for fixed or mobile cameras, and these are usually optical cameras, and that brings the question of privacy right away. Obviously, when we have that information, we can do a lot with that information because and this information can be carried using cell phones and mobile cameras or drones or anything possible. And they can actually communicate with the receivers or cell towers or fixtures, the smart fixtures in the environment. So it could be fixtures of the buildings, a fixture on the streets, and so on. And we can actually use that information in case of emergency, in case of wildlife tracking, in case of fires, or many other things. We can not only locate the location of the event, but at the same time gather more information about what's happening. So this is very important. Tracking people is not a good thing in many ways, and it's just seemingly invading the privacy. But at the same time, imagine yourself in a fire rescue situation. You would like to be found. So that is an interesting thing. So there is a trade-off. Where do we stop, and what is happening with the privacy? And is there any way that we can track people without collecting biometric information or identity information? There's so many different ways that we can do this. One is using AI in a different way, not storing everything on the servers, and meticulously being on top of what we are gathering. And obviously, we need to really pay attention where we are operating, because in different environments, there are different regulations as well. So privacy is apparently an important issue here, but there are solutions to that as well. Let's move on, and we'll just explore those possibilities.
Yeah, I would just add to this is that with the push for edge technology and the ability to do things more remotely, right now, most of the data, if it is being collected, is being sent to the cloud and then analyzed. If we can start analyzing at the source and making decisions closer to the source where you're collecting the data, that will be a turning point in being able to apply these in a cost-effective and efficient manner. And
very good point. Very good point.
In using infrared, using other technology to help you spot problems, and then stream through the cloud later if you do find things, may be what we will see next in the upcoming years, I would imagine. So just want to add that color. So the next slide here is a rather full slide, which I'll try to explain. It's the trade-offs, as we've discussed, to create a secure work environment. And we're talking secure not from a security perspective, but a well-being perspective, and the trade-off of privacy versus no privacy. So on the y-axis, we see safety, well-being from low to high, and on the x-axis of both of these 2x2s is from low to high cost. And so in the bottom left is if everybody is self-monitoring everybody else and to keep everybody safe. So everybody's watching everybody, making sure you're safe. That's one approach. The other approach on the far right upper corner is where you're looking at something where there's you're being ID'd as soon as you walked in. You have access codes. You may have your cell phone is recording who you are. Your image, your face is being tracked, and you're being recorded. And the system knows who's in the room, so to speak. And then if there's somebody who shouldn't be in the room, they would be alerted. The guards would be alerted. If somebody's behaving in a way that is not quote, quote, normal based on algorithms of how people normally behave, then that would also trigger something. So that's very sophisticated, but in the upper right-hand corner, you lose your ability to protect your identification. And we all know that our IDs are at risk with cybersecurity issues. Once we're in the cloud, we're always in the cloud. So there's a balance here is, can we remain safe at a lower cost on the left-hand side? Or, what China and a lot of countries in Asia and even in Europe are moving towards that upper right-hand corner. And what are the trade-offs? Only 10% of America today are using this technology. And a lot of this technology has been around for over 10 years. It's not brand new technology. I think AI is more powerful now because our computers are more powerful and we can do more things. But quite frankly, most of this technology has been around for a while. And the other countries around the world are leapfrogging the US in applying this technology. And we wonder, is it privacy that's preventing it from being performed in the US? Or what are the things? So we welcome your thoughts, as long as they're not politically, they're not from a political perspective, but we would love to hear everyone's thoughts on this. And then I'll open it up to Bulent and see to add some color here.
Well, we put a lot of effort into this slide and spent a lot of time thinking about it because to us, this is the crux of the matter. Everybody wants safety or a feeling of well-being, but there definitely are trade-offs. And one person comments, too many lawyers in the US.
Yeah, that came up in our conversations.
Yep. And, I think Europe has been focused more on privacy than the US in the last, half a dozen years. GDPR is probably 5-6 years old at this point. And California has made some progress in that direction, but I don't know of other states who've sort of pushed forward with that. I'm curious as to people's point of view, and we have a polling question coming up because this, to me, is, what are you willing to trade off for privacy?
And what are your thoughts about the infrared technology where the person's identity can be
hidden?
Yeah. And we can do a lot of the analytics remotely without going to the cloud. And then only when there is a situation that is a person laying on the ground or a person in a unfortunate physical predicament, that it sends an alert. Because you always wonder, you walk to the parking garage, if you fall down, there's all the video cameras all over the place. But if you fall down, those video cameras, there's nothing in the software to alert anybody that you
Right.
fell down and hurt yourself, and you're by yourself. You tripped and fell down the stairwell, which is always a scary thing for me. And especially as you get older, you're down this dark stairwell. If you fall, does anybody hear you? You're not in the woods. you know, if the tree drops, does anybody hear in the woods but you? But, you're in the stairwell. Does anybody hear if you fall? And there's a video camera and you're thinking that somebody's watching, but there's nobody watching. And you lay there for a half an hour, wait for help and hope somebody happens to come up through that stairwell.
Or you can reach for your cell phone and call.
Or you can reach through your cell phone if you have your cell phone.
Right.
Yeah, but I think we rely a lot on our cell phone. So maybe the answer is all on our cell phone. Maybe that's why there isn't a push. But love to hear some comments from folks. Is there any comments in the chat?
Not yet.
All right, so we'll move on to the polling question. This is kind of maybe a little bit direct, but again, we don't know who. These are all anonymous questions, so we really don't know who's answering the questions. So you are private. Your questions are secure here. So how much privacy are you willing to give up to gain safety? A, you feel more comfortable with the Big Brother approach where the security is paramount regardless of total loss of privacy. Safety comes first at all costs, so to speak. B, you're willing to trade off some privacy for security. The video is destroyed in 72 hours or written over, which is a very common practice. I embrace GDPR and like my privacy. GDPR, Bulent, you want to explain what GDPR is? Are you on mute?
No, I can explain it.
Okay, go ahead.
GDPR is the European system of what's acceptable. You have to opt in Europe, which is not true in the US. I think it is in California now, but you're asked about collection. I mean, and some US companies are definitely following that now. And you see that people have to ask on the cookie side every time you go to a website. And, you can say no. And I do personally.
I do too. Great. And then the last one here is, do you want to compromise? I don't want to compromise my privacy at any cost. So let's see what the responses are. We're in the middle of the road here so far, but let's give it a couple more minutes and open it up for some chats. I see the chat box going a little bit. Maybe there's some interesting questions there.
Somebody comments that I guess the law in California is CCPA, right? Yeah.
And there was a typo in GDPR.
Oh, right. GD.
GD.
Correct. Oh, it's not GG. It's DD. Yeah. Correct. Thank you, Jimmy.
Yeah, that's what threw me off.
Yeah. Thank you.
Yeah. Okay.
Yeah. I think older Americans, I mean, this is what I think, but I don't know. I think older Americans, my guess is, embrace GDPR more. But younger people, having grown up with Facebook, don't think about it as much. I think when you grew up, in what decade, makes a difference in how you view this stuff.
Sure. Absolutely.
Any other people agree with that? Or disagree?
Well, even here, the distribution is towards privacy.
Yeah.
We're at the hour, Jim, so we have to.
We're at the hour, so we're going to wrap up now if there's not any more questions. Okay, so we have.
I hope some of these questions will be thought about and join us again on August 3rd when we really want to explore many of these questions.
Yeah, and this is the wrap up. Bulent, you want to do a quick wrap up here of
Well,
today?
as usual, we would like to conclude with the simplest solution possible. So there are so many different solutions that we can come up with, and we can make the problems more complicated than they actually are. But basically, we would like to go with the simplest and the cheapest solution all the time. Video infrared or even optical infrared is a viable solution when they are backed up with AI and machine learning. And that's the very key point here. And Jim made this several times. Actually, we can have the video, but unless we have a logic behind it, it's very difficult to use that information.
All right.
We just had some comments from two of our attendees. One who shared his age was 27 and said that's Jimmy, and he said he was very concerned about loss of privacy and rights from, as he says, a corporately controlled government. And that's very encouraging to hear. Thank you, Jimmy.
Yeah, I have some nephews that are of that liking.
Yeah.
They're very concerned about it.
And Bob, who's a little bit older, you know, yes, George, the slides, everything will be available on the, you'll be getting an email telling you to go to the link and everything's available, slides and video.
And you can reach out to us anytime you want if you have questions, if you have business cases, we would be more than happy to hear.
So this is Bulent last night. I believe he could do this. You wouldn't think he could do this, but he's a Canadian.
Getting ready.
You know, Canadians, you know, they can do anything.
Working on it. Working on it.
I mean, just look at him go. He just wanted to top off this webinar with just a little bit of a spin move. You know, you can tell it's him by looking at his hair that that's Bulent.
Exactly. Exactly. Without my glasses.
Yeah, well, you had to take your glasses off. You
Yeah.
lose. So thank you, Bulent, for that spin move to end the webinar.
Thank you very much for all.
Wonderful. And you hardly worked up a sweat at all, which is also amazing. But that's, you know, only a PhD can do that, not work up a sweat and do some breaking. But
so, thank you.
Thanks everyone for attending the webinar. We appreciate it. We appreciate your time. As I mentioned before, we do have a few webinars coming up that please do reach out on the 15th. And we'll be back here in the beginning of August for a chat, a nice relaxing chat. You bring your wine. It's August. Bring your wine or your beer or your cognac, whatever fits your whistle. And
just to reiterate, anybody who's interested in helping us with our democratized AI mission with students here and abroad, love to hear from you. There's definitely ways everybody can help no matter where you are in the country.
Yeah, it's a wonderful program. Please do reach out. So, thank you, C. Bulent, any closing comments? Bulent?
I think that's wonderful. Thank you for the opportunity. Thank you for everyone joining with their comments, enhancing all the content. Wonderful. Thank you very much. I'll see you in another webinar.
Yes.
Thank you, Bulent.
Thank you again. And yes, we just got a comment about the topic. And this is a very important topic, and AI plays a significant role here. And we'll talk more about it on the 3rd and at future webinars. I hope that we stimulate your thinking. That's like one of the things we hope to gain from this.
Yes. Thank you all for joining us and your participation. We really appreciate it. And we wish you all a safe summer. I know that a lot of you will be traveling, so be safe. Take care.
Yes, and in our last webinar, we asked how far from home people were planning to travel, and we got people were probably not going to travel too far, like 100 kilometers, 50 miles, but enjoy your summer outings wherever they take you.